Today, we will be mostly discussing around rendering patterns. Rendering patterns in the more sense of like what are the new things coming with React. We have beautiful panel members here, all experts on this topic. So what we'll do, like we'll start with introduction. And with the introduction, we have to also add like what is the one thing in React you love so much? Or what is the one thing you are excited much about React, like a future React? So maybe let's start with Akansha.
You should start you with
Oh, I will introduce myself at end.
Okay. Hello, everyone. I'm Akansha. Okay. Thank you. So yeah, I'm a front-end developer and a FOSS enthusiast. I work with the Excalibur core team. So my most favorite thing about React, I would say selective hydration. But to add the most excited thing I'm actually excited about, I would say React Server Components is one of the most things which I'm actually very excited about. So yeah, that's all about me.
Cool. Hey everyone, I'm Pratik Bhatnagar. I work with Coinbase as a front-end engineer, and one of the things that has always excited me about React are the people, the React community, and the brilliant things that we come up as a community.
Hello everyone, I'm Mateus. I work as a front-end engineer at Medallia. I guess that one of the things, and I mentioned that in my session, but one of the things that has always hyped me about React is how it embraces a couple of things that are happening in the web and learns from them, but also at the same time it pushes the web and other ecosystems towards the future. And like in the session I mentioned the web, but we could think of Swift and native iOS and native Android and other things learning from React, and the idea of building building UI in terms of functions and etc. So I have always loved that. And one of the things I'm hyped about, I don't want to say server components, so I guess I want to see what's going to be the next 5 or 10 years of React in this whole era of meta frameworks and that kind of thing. So how React is going to become the library people building frameworks use to build frameworks, and regular front-end engineers use those meta frameworks. Yeah, that's pretty much it.
Hi, I'm Teju. I'm a developer relations consultant. And the thing that excites me the most, has excited me about React for many years, is definitely the community, like you said, but also the component model and the way that everything composes, the composability. It's been around for 10 years and it's only getting better. And I'm convinced nobody does composability and API design as good as React. So that for me is really exciting.
Awesome. So I'm Sudhanshu. I'm working as a front-end architect at Prophecy. I have seen React from the early days when it was used inside a script tag. And now there are a lot of new things. And what excites me most about React is like all the new patterns which it is trying to bring is mostly tailored around the user experience. No rendering, like they are not targeting make rendering faster and faster. It's more about like what user need, how we can improve the user experience. So that's something which excites me most. With that, I have a question on, so basically, one of the early pattern React added was you can use React at any, like all the platform, right? Mobile, client, or a server. And most of the people started using React on the server side for improving the rendering, like a first rendering performance. So Akansha, with you, I have a question. Basically, how the new streaming capability on the server-side rendering, that is enhancing this whole experience?
So I think before we get into how server-side streaming actually enhances the SSR, I would like to go a little back and just let's understand how it used to work earlier, and what were the drawbacks and how actually streaming enhances it. So SSR, what happens is, you fetch the data from the server will be rendering the component and it will be sending the HTML back to the client, then the JavaScript will be loaded for that component, and then add the event handlers for the hydration, and then that's where the page becomes interactive. So since we are sending the HTML from the server, so at least user is seeing something on the web page, though they cannot interact. So there were a couple of drawbacks in this. So since we are fetching the data from the server, now let's say that there is your server is for some reason slow, and that's not really in your control. So it will actually delay the response from the server on the client. So basically, getting that HTML from the server will actually take more time. And due to that, what would happen is your JavaScript loading will also get delayed, because the whole HTML should be coming to the client from the server, and then post that only the JavaScript can be loaded for the component. And so this is one of the drawback. Now let's say you got the data from the server, so you now have the HTML. The users can see the web page, but they are not able to interact. So second thing is that when you actually start loading the JavaScript, let's say for the component there is some complex interaction logic due to which the JavaScript loading is taking more time to load. So due to that, actually, your hydration will be delayed, because until unless whole JavaScript for the app is actually loaded, your hydration cannot start. And that was the second drawback. The third drawback was that until unless your full page is actually hydrated, you cannot interact with the page. So these were like the drawbacks. Now, as Shubhanshu mentioned that how SSR streaming actually helps us. So let's go back to the first drawback, fetching the data from the server. If that is getting delayed, the JavaScript loading is getting delayed. So for that, now since with React 18, we have the SSR streaming. So we don't really have to wait for the whole data from the backend to load. Instead, you can just wrap it with suspense. So it will actually start streaming the content. It will send you a spinner, and users can actually start seeing the spinner instead of, let's say you are loading some tweets from the backend, so you will see the spinner instead of the tweets. And when your data is actually fetched on the backend, they'll actually send the HTML content, which will be actually replacing that spinner. So this is basically overcoming the first drawback. So it's not like you have to wait for the whole data to come from the server before actually you start loading the JavaScript. So that is how I would say that the SSR streaming is actually helping us. Yeah.
Anyone want to add? Okay, so I have a question on this, follow-up question. Basically, you mentioned about hydration, right? And with streaming, now we have a partial hydration. So basically, how this partial hydration work, and the partial hydration also can mean that how do you know which one to hydrate first? So how React solves that?
So I think with SSR streaming, we are actually overcoming the first drawback of fetching. We don't need to fetch the whole data from the server to wait for the loading the JavaScript. That is solved. Now after this, I'll also actually cover the second drawback, how that is improved. So we also have the React lazy support on the server side now. That was not earlier. So now what happens is, let's say you are loading some component which has some complex interaction logic which is taking some time to load. So we can actually load that lazily. So we don't need to wait for the whole JavaScript to load before starting the hydration. So that is solved. And when, let's say, your whole JavaScript is loaded, now the last was that whole page needs to be hydrated before, making the page interactive. So with that, selective hydration has actually been pushed in React 18 as well. So with that, what happens is that we don't need to wait for the whole app to be hydrated at once. What happens is, whichever parts are ready to be hydrated, they actually start getting hydrated. So it's like, let's say your sidebar was hydrating, and let's say you click on some button somewhere. So now, since React has this concurrent features, so with the help of that, what is happening is that button hydration will be, even if it's not ready, the button hydration will be actually taking more priority. and that will hydrate first, and the sidebar hydration will be paused for that. And once that is done, they'll again go back to the sidebar. So it's like hydration is now interruptible as well. So that's how it is actually making the UX way more better than how it was before, because earlier we need to wait for the whole page to be hydrated before we start interacting with it. But now we can start interacting with the parts of the application which are actually ready. So that's how selective hydration or partial hydration is actually helping making the UX a lot better.
So I have a question with you, Pratik, on the same. So there are a lot of other libraries which had like this partial hydration or island architecture in general. It's not new, right? Like Astro had this, and a lot of other library. And with React also, people had their custom solution. So how do you think the React differs? Where it shines, where it not as with other solutions?
Right. So, okay. There are a few things. So one thing, as you said, right, we have had island architecture. I guess that's from Etsy. There we have had Astro. We have had a bunch of things which have done selective hydration, but the selection was Boolean. Like either something was hydrated or something was not hydrated. The ability, the beauty that we are able to tie this back to suspense, right? And we are able to take full benefit of concurrent features and pause a particular hydration and reprioritize another part of it is basically what is the most biggest differentiator of it, right? We are not saying that we are not letting it on developers or the user land code, where somebody needs to tell us that a particular section, a particular article does not need to be hydrated. You can say everything can still be interactive, everything can still be a client component, and the library or the framework can still choose that I can probably defer the hydration of a certain part, right? There are other ways and other enrichments that we can potentially build on top of this. But as of now, we still have the capability of, hey, user is hovering on a particular section or user is about to interact with a particular button, and let me pause my current work at this point, current unit of work at this point in time and reprioritize something else. That's like one of the biggest key features, right?
Yep.
And the cognitive load on developer is much less, that I have to be very explicit and tell that something is lazily loaded or something is out of viewport, and like something is helping me out of the box, that hey, you probably don't need to think about this. If at runtime something changes, I can take care of it.
Yeah, and React also does that, right? That if you click something, they will prioritize that hydration first, as Akansha mentioned.
Yes,
like
exactly.
those things were on developer like they had to selectively tell like how something should be hydrated. Cool. So as you mentioned, concurrent feature, we'll go more into concurrent thing. Matthew, basically, I want to hear from you. So most of the library, I would not name a library, but a library try to improve rendering performance. Like they try to make it faster and faster, but with the concurrent features, the perceived experience is the core of React now. So how do you feel like how this changes how user develop application?
I think this is a different take. So you mentioned other libraries are trying to improve perceived performance and etc. And I think that is, for example, the take from Solid of having fine-grained reactivity and etc. I think that the set of concurrent features was one of the things that React had at hand, because, and this has been very well pointed before by people like Rich Harris and the Svelte folks, etc. React had it's not a problem, but it had an aspect due to how Virtual DOM works and etc. And throughout the time, React had to come up with a lot of ways to work this around. So React started 10 years ago as something, it was sold, if you check one of the first presentations by the Facebook guys back at the time, it was sold as something that you don't have to worry about performance. And actually React was this thing in 2011, 12, something like this. And throughout time, things started to pop up, and suddenly we had to worry a lot about performance. So we had shoot component update, and then React.pure component, and then the hooks and the memoization, and etc. And most of that came as a drawback of Virtual DOM. And then people were able to address this in other ways. Other libraries optimized a lot Virtual DOM. They were still doing Virtual DOM, but really fast. That was the case of Inferno, and then the case of Preact, and etc. I think that concurrent React wasn't like a medication to that like other features were in the past. But it does improve a lot, and that was basically one of the conclusions of my talk. Like a lot of the, not only transitions, but the things it's doing under the hood, like the automatic batching of things, and also what she talked a lot about, the thing of selective hydration, and also how React is clever enough to prioritize hydrating what the user interact with before the rest of the things. And all of that, I think I see it with very good eyes, because for the first time, I don't see those as medication to some of the Virtual DOM drawbacks, but actually some original performance work React was doing. That was interesting. Yeah, so I'm afraid I might have tangented a lot of your questions. So
No.
what would be the, what was the bottom line of the question?
Basically, like why pursued experience matter, and why React is focusing more on that.
Yeah, I guess that why it's focusing more on that, it kind of traces back to 2016, 17. You probably all recall there was this epic talk by Dan Bramov when he was announcing both what would be suspense in the future and what would be concurrent React. And at the time, he basically focused, okay, when you're building an app as a developer, your users, they have two problems. They have one problem when they're doing CPU-bound stuff, and they have a problem when they're doing I/O-bound stuff. And suspense is going to be the thing for solving the I/O-bound stuff, the I/O-bound issues at the time, and it did improve a lot. And then at the time, we called that time slicing, and time slicing was the promise to fix those problems. And for a lot of years, we didn't know what was time slicing. We didn't know what was concurrent React, what was concurrent mode, what was under this umbrella of features. So I think that this whole thing started being prioritized. If I were to guess, I'm not part of the core team, but if I were to guess, both optimizing for I/O-bound and CPU-bound operations started back at the time after the whole Fibers thing. I mean, Fibers kind of set the basis for that, but after the whole Fibers rewrite. And yeah, it just took us a while to see the end results. And that's one thing Dan has said, I guess. Like, it's a lot of those things, in React Server Components is another example, they're very clear in their minds. But communicating that to such a huge community like React is really challenging. So that's why it takes a lot of time. For example, we're only now, like ever since the last year, realize what the whole concurrent thing is all about, and what it has to do with suspense. Why does it impact hydration? Like, were these related in the first place? So we're now figuring out that, but that's something that they had in their minds for 5, 6 years from now. So it's been a priority for years now. It's just that it took a lot of time for us to see it happening, I guess.
So I have a follow-up question with you, Tejas, since you are in.
Sorry.
Yep.
I just have a point to add there. So a lot of libraries, a lot of frameworks, they use benchmarks, they use ES benchmarks, bunch of things. I guess there's a shift in looking at finding the problems, like what are the problems that we are chasing right now. As a front-end community, we have chased how do we do composability for a long time, right? How that was a hell with jQuery and other imperative things. We have chased like how fast can we render like 1,000 items row or 1,000,000 items row on a page. right? It's basically the shift in that culture on how we are breaking the, direct correlation of code versus our JavaScript bundle, let's say. That's one theme of where server components come into picture. There's another, like, how do we fix loading states? iOS and Android have fixed that for a very long time, but like they're also platforms, right? How do we as a library or as a community or as a meta framework or a web framework start focusing on them instead of, without screwing up our ES benchmarks, right? So that's like one big shift that has happened in the community and with the library authors themselves.
Yep. And since we are talking on the community side, Tejas, wanted to hear so concurrent feature kind of break how the earlier rendering used to happen, right? Now things are happening in parallel, and because of that, this lot of assumptions which the community library were making, that has been broken. So there is a little bit pain on the community library side where they have to involve those changes on the side, and sometimes it's a little bit hard as well because it changes how library works. So do you see any changes are happening around that?
Yeah, definitely.
On the adaptability side, basically?
Yes. So, my talk earlier about server components is similar, right? Changing to adopt server components, what you essentially have to do is re-architect your entire application. And you may be using server-side rendering, you may be not, but still, it's now server first. You have to use a server. And also, there's compatibility issues. For example, client components cannot import server components, because if they import something that reads from the file system, the browser doesn't know what FS is. And so you can. So if you have a client component that you npm install the tweet component that will call the Twitter API. Unfortunately, you can't anymore, but you used to be able to call the Twitter API and then render a tweet. Now, if this is a server component, first of all, you don't know unless there's some convention in the npm package, server component something. I think that's a good idea to make it explicit. So maybe you don't know, you just npm install React tweet, try to render this in your client app, and it'll fail because it can't. And this is a huge burden now for library authors. There's a great blog post by a good friend of mine. His name is Lenz Webertronic. And he's the maintainer of Redux Query Toolkit, just Redux Toolkit in general. And he was just talking about, I love server components, but as a library maintainer, it's super hard because people want to use my thing with server components and they can't yet, and I can't add library support to it because server components are experimental. And so these changes, whether it's concurrent features or server components, does make the lives of library maintainers very difficult. There's no question. I think the React team is doing great work to help them and work with the library authors, but now the community is so big and the team is so small, the core team, that it's starting to show. And it's almost as if they need like really good DevRel consultants or something. But I think I think that's kind of the problem is that the team that maintains this stuff is too small and the community is just so large. And so, yeah, I don't know the solution, maybe like a big Discord with every library author or something like that, but it's definitely a problem for sure.
Yeah. And I think this is a very good opportunity for everyone in the community member. Like I've been asked like how to start contributing on open source.
Yeah.
And this is a very great time, like because new things are coming and things are not yet compatible. So we can make it compatible.
Yeah, just one thing to add is I love that they just mentioned concurrent, the whole concurrent thing, because it also happened. It's just that we RSC, we're seeing this at a whole different scale. But 2 years ago, you would see a lot of GitHub issues, especially I even shared something like state management libraries. Hey, my library is broken because of concurrent features or weird glitches would pop up and etc. So it's something we've been in this place before. I guess it's just another scale, but I think that eventually things will be sorted out with some really good education work and developer communities and stuff.
One thing to fully answer your question, because you asked about adoptability and adopting these things, and I had a great conversation out there as well in the hallway track. People saying, I want to use this library, I want to use Redux Toolkit, but I can't yet, but I want to take advantage of server components. And what I said to the person, and I think this is right, is to not be ashamed of client components. A lot of people think they include, now, if you want to mark your client component as a client component, you have to write use client at the top, okay? And because server components are so romanticized, server components are so, wow, it's amazing, people are ashamed to like write use client. And in terms of gradually adopting it, I think it's a very fair thing. If maybe your root component is a server component, but everything under can be a client, that's totally fine, especially if you depend on a library that will not work on the server. Everything can be a client component, sure. And then gradually, one by one, you can remove use client and turn slowly things into server components. But everything doesn't have to be a server component from day one.
I assume it can happen opposite as well, right? Like things is in client and only the piece you can start migrating to server component.
Exactly. So you can start piece by piece. And if you have a lot of client components, this is important for you all to know. If you have a lot of client components, it's not that your app is bad, it's that your app is a React app. Because before server components, every app is full of only client components. So you're not really losing anything, you're just being the same. And that's totally fine. Right? Server components is plus plus, it's not minus. Yeah.
I think since you are the server component expert here.
I'm not.
But I just have a question that with this concurrent features, the suspense and with the server components, I feel that when it's ready, like right now, it needs to be made compatible with the libraries. The end goal of the core team is to reach a stage where the app users don't really have to worry about anything. They just, like, let's talk about start transition. It should be integrated in the router libraries. So we don't really have to, like, we as app users don't really have to worry about those things, but it will take time because it's like a community effort and that takes time. But one thing which eventually we might have to end up doing is with these concurrent features and server components, it feels like we might have to restructure our components into more smaller and smaller components. Like today, if I'm writing the code, maybe, I have the server logic there, I have the component there, and it feels good to be, to have everything at one place because it's a single component. But now, if I want to, move to, let's say, server components, let's say 6 months later, or I want to experiment it, I have to restructure the code in that way. Plus, with the suspense as well, we are essentially breaking it into smaller components, right? I think it's kind of mixed feedback. Some people would be okay with it, some people might not be okay with it, because if you want to use, you have to break it. You have to break it into different files and those kind of things, right? So what is your opinion on that?
That's a good question. I think personally that breaking it for the case of server components is worth it, because I think we should have been writing React this way all along. Because if you have an interactive, so by breaking for server components, you would break your components at the interaction boundary. So if you have a long tree with a lot of business logic, etc., and then you have like this one button with a click event handler, what you would do to break it or restructure it is you would take this button out into its own client component and you would reference the client component. That's the breaking, right? So anywhere there's an event listener or state, that's the point where you break it. And I think if we were doing this before, then it wouldn't be breaking. And we should have been doing this before, really, because that's how React's supposed to be. So it's, in a way, it's forcing us to make things more React-y, is my opinion on this. But I have a follow-up question for you, since you're the partial and selective hydration expert, which is, it's a very basic, it's a binary question, really. Do we know how, because I've not played with selective hydration, do we know how React prioritizes what to selectively hydrate when? Does it create some type of like AI-based user interaction graph or?
As far as I know, like I haven't deep dived into the code, but as far as I know from the top level, it basically, I think it basically checks, so basically the time difference between the switching, let's say if you're hydrating a sidebar and let's say you click on the button, that switching is actually done in with very small duration. It feels like it just happens behind the browser tick, and that's where we as users feel that it's like the hydration is like just happening instantly. But there is some, I think they run it over some kind of DS they are maintaining, and they just do it on the priority basis. But yeah, I think to answer it more in depth, I will have to, I mean, I'm not sure about how it actually works internally, but this is something which I have on top of.
Yeah, I wanted to quickly follow up. As far as I know, the heuristics they have for hydration is purely based on interaction and what could be, what the user interacted with before, so they prioritize that. I don't know how to.
So I think I know about it. So basically, it's more on how you have written the suspense, like where you have used suspense. So it depends on the order. So first, it depends on that. Basically, it will prioritize based on how you have written your suspense in your React boundaries, and then it prioritize depending on like whatever user interacts with. So if user interacts with one section, it looks for the closest parent suspense boundary and try to hydrate that first. And also it looks like whether the JavaScript is already loaded and it just require a hydration, or the JavaScript is also needed to be loaded. So in case, let's say JavaScript is loaded, but the hydration is not completed. So what it does, like it hydrates in a synchronous way, so that like whatever you clicked, the hydration happens, and the same click will follow through. Like user don't have to click it again. But in case of, let's say, JavaScript is not loaded, then it would act as a, like earlier they were thinking about recording click events, but that idea didn't turn out very well. So now it's very simple. Like if some JavaScript is not loaded, it would act as a previous, like a SSR thing, where user have to click it again, but it's fine. Like they will prioritize the loading of JavaScript first.
I just had another thing related to your question to him, and this concern is actually quite valid. So there is a post for years ago, like more than a decade. It's called "What Color is Your Function?" And this post is actually about when we were switching from callbacks to promises, because that was a switch where basically if you made something a promise, then you would have to make what was wrapping it a promise, and then and so on up in the tree until your whole app was a sync await, or then at the time. And I saw a couple of weeks ago someone saying that we need a post like "What color is your component?" because the person had the exact same concern of, okay, I'm migrating towards React Server components, but because of the limitations of the different dependency trees of servers and clients, suddenly something had to become either one or another. So I don't think people came to an agreement on that, but that is a pretty valid concern.
So follow-up question on, again, on the adaptability, right? So Meta framework plays a very important role.
Okay, we have 5 minutes.
Okay, so I can complete this question. Meta frameworks have a very important role on the adaptability part of this one, right? But there are a lot of meta frameworks. For them, like how they are prioritizing this new concurrent features, or let's say as React Server component, or any of streaming thing.
Okay, let me try to understand how the web frameworks or the meta frameworks are prioritizing.
How they play a role in.
Oh, how they play a role. Okay, cool. So there are multiple things that you want to do when you like land a new feature, right? Certain things are experimental, so you can't just release them in the wild and expect valid feedback, right? So I guess that's one of the most strongest pillars of pairing up with meta frameworks. Let it be library authors, let it be browser authors, or whoever they are, right? Pairing up with frameworks which land to masses, right, and help people go from 0 to 1 gets valid feedback, right? Because these are the audiences which can play around with anything experimental and doesn't have like $1 billion company riding on it, right? So pairing up with these frameworks, get library authors, get browser authors, first-hand signals from real user metrics is one. That's like one of the biggest things that meta frameworks bring to table when we are talking about experimental stuff. Next thing is basically what are the challenges that users are facing. This is, I know Gatsby did this, I know Vercel does like anonymous telemetry, right? Anonymous event collection. It's not exactly the data you need, right? Until you are paired up with one of your clients, but you still get right signals of where your users are facing challenges, right? Is it about loading paradigm? Do we need to fix our loading pipelines? I'm citing exact examples of what I have worked with in my previous jobs with meta frameworks. Right? Do we need to fix like loading pipelines? Do we need to fix the way that things get interactive first, or do we need to fix like our data loading? Right? These are some of the feedbacks that meta frameworks can get. Imagine if everyone is doing their own Webpack scaffolding, right? And now GraphQL can never ever get a sense of how are people facing problems in loading data, right? Given that there is a huge corpus of users which use Next.js, which use SvelteKit, or which use Astro, and now I have pointers from all of these. I can find commonalities, and as a library author I'm speaking, and now I can go back and say that, okay, there's a probable thing that we need to fix in X, Y, or Z field. Right? That's the single most important thing for authors and any other person involved in web ecosystem that web frameworks bring to the table.
Yep. And since we have 2 minutes, I'll extend on the same question. Basically, you mentioned about this meta framework collecting telemetrics, like how user is using app, right? I'm not sure if they give a way to measure this performance improvement, like let's say if you're using RSC or any other features. Not very sure, I haven't used it, so not very sure. Do you know that?
Yes, right. So some does, right, which gives you first-hand performance observability solutions out of the box. And with that, like if one thing is like if you are a partner client, then you have like 100% access of your RUM data or whatever your organization allows. But whatever is the extent of that can be collected anonymously, right, and can go through with GDPR compliance, can definitely be taken into consideration, right? How is your app structured? How many people are using? These are very basic examples, like how many people are using suspense, how many people are using server components actually on there, because all you need to do is like look at that code and not really anything else, right? Not collect literally any other details. Or how many people are taking care or installing ESLint. How many people are installing, let's say, if we have a rule for server components, right? And you get those ideas back.
Cool. Yeah, and yeah.
I think this is last promise. So this is actually for everyone. So if you are interested in I think as Tejas asked, right, how does selective hydration work internally? I am not able to recall right now, but I think there is a very good thread on the React Native working group about the same, and they have it's actually by the React core team, and they have explained it in a very well way. And I think for the React server components also they have a working group. So I think if you are interested in deep diving into how these things work internally, I think you should definitely check out the deep dive threads if you are interested in knowing the internals. So just wanted to add this.
Yeah, and we will have more discussions on the breakout room, so you can continue to ask some questions around it. Cool. I think time is up. So yeah, thank you everyone.